All right, so now the question is, how do we solve a quadratic equation if it's not factorable? Just like that question that was in the warm-up, we had x squared plus, what was it, 4x plus 12 equals 0. We weren't able to factor that, and we couldn't solve it by the zero product property. So now we're thinking about, well, how do we solve that at all? And so now this is where we're going to use the quadratic formula. So the quadratic formula is going to assume, the first thing you need to know about the quadratic formula is that it assumes that, if you have a quadratic equation that is in standard form, right here. So this is a big assumption. You need to have an equation in standard form before we can even make use of this shortcut or pattern. And if you want to know how this equation comes to life, you can just Google or YouTube some how the quadratic formula is derived, and that's through completing the square, or one of them is through completing the square. We just didn't have time to do that section, completing the square, under these circumstances. So definitely check that out if you're interested. But here is the equation. So if we have an equation that is in standard form, then we can take these coefficients a, b, and c, and we can use those coefficients to plug in. Right here we have negative b plus or minus the square root of b squared minus 4ac all over 2a, and that's a quadratic equation. Now this right here, the square root of, I should say, right here, b squared minus 4ac, this is called the discriminant. That we'll talk about in a little bit. This is called the discriminant. And I would say that's kind of like the heart of the quadratic formula. It tells us a lot about the situation, and we'll get to that. But if we simply take the a, b, and c values and plug them into this formula, this pattern here, we're going to solve for, or say what the x values are for the problem. So the discriminant. The discriminant is in that formula that we just saw, is really the value, or the radicand, the technical term, is the value underneath the square root symbol, which is b squared minus 4ac. That's typically what you would evaluate and figure out first when you're trying to solve the problem. And based on that number, it actually tells us and predicts what type of answers we're going to get. So, for example, b squared minus 4ac, if we calculate that number and let's say that it is negative, it's a negative number, then that is going to tell us that we are going to have two answers. But they're going to be imaginary numbers, imaginary solutions. So we're going to write in here, we're going to have two imaginary solutions. And again, by imaginary, we're talking about what we talked about in 4.6, the imaginary numbers. We're going to have something with I in it. We're basically going to have the square root of a negative number. And what that looks like on a graph, putting this in your notes, if you were to graph a quadratic equation that is y equals, whatever, and you were to graph something, the graph is going to look something. It could look like a lot of things, but if you have two imaginary solutions, you're going to have no x-intercepts. And I'll show you what that means when we look at Desmos in a little bit. But we're going to have no x-intercepts if you were to graph that equation on your graphing calculator. Okay. So the second option, if we calculate the discriminant and b squared minus 4ac happens to be 0, which can happen, then we're going to have exactly one answer, and it will be a real number. It'll be a normal number. So I'm going to put here one real solution. And what that would look like if we were to graph it is this. So let's say I have graph here. That means I would have a parabola, okay? A parabola with just one solution, or in this case, 1, 0, or 1, x-intercept would be a parabola that comes down, it touches the x-axis in one spot, and then goes back up. Or it could be a variety of parabolas that do that. But we're going to say here there's one x-intercept, which corresponds to there's one solution in our problem. And then the third possibility is that our discriminant just is positive, which is very common. If we have a positive number for our discriminant, b squared minus 4ac, then we're going to have, again, two answers, but they're not going to be imaginary solutions. They're going to be real solutions, real numbered solution. So we're going to put two real solutions. And what that's going to look like is if we were to graph that quadratic, then we'd have some type of parabola, but we'd have one and then we'd have two x-intercepts. We'd have one here and one here. We'd have two x-intercepts, or two zeros in that problem. So again, the discriminant is part of the quadratic formula, and the discriminant sort of predicts or gives us information about the solutions or even the graph of this quadratic without actually going all the way to the end of the problem. And you should make note of these things, and we'll refer back to them. Okay, so let's try an example. Let's do example 1. And example 1, the instructions for example 1 would just be to solve that equation. And so if you want to solve this equation, we're going to put it into standard form first. So we're going to say, okay, let's say x squared minus 5x. We're going to subtract the 7 from both sides. Subtract 7. So this is going to be minus 7 equals 0. So now this is in standard form. And now when we, in algebra, we have a bunch of different tools in our tool belt to solve things, to evaluate things, to simplify things. One of the tools is, hey, can we factor this and solve it? Right? So if we were in 4-3, 4-4, we could try to factor this and solve it. And sometimes that'll be a very quick way. If you investigate this a little bit, you'll notice this is not factorable. This is kind of like the warm-up question, not factorable. So therefore, we have to use the quadratic equation. So what we're going to do is we're going to use a quadratic equation. But before that, we're going to calculate the discriminant. Remember, the discriminant, which is b squared minus 4ac, is part of the quadratic formula, but we're going to do that first. So in this problem, we're going to calculate b squared minus 4ac. Well, it's important to realize here that the a value is 1 here, right, because it's 1x squared. The b value is negative 5. And the c value is negative 7. So the a value is 1, b value negative 5, c value negative 7. So if we calculate the discriminant, we're going to get negative 5 squared minus 4a, and c is negative 7. So this will become 25 plus 28, which means we're going to have 53 there. That's going to be 53 is the discriminant right there, which means, if you think back to the chart that we just made, that when we finish this problem, we are going to have two answers. We're going to have two real numbered answers. Okay, and if we were to graph this quadratic with a y equals, then that it would be crossing the x-axis in two places. Okay, but all we're trying to do here is use a quadratic formula. So now if we kept going on this, right, the quadratic formula states that we have negative b plus or minus the square root of b squared minus 4ac, all divided by 2a. Right? So we just did part of this. We just actually did b squared minus 4ac, right? We know that this right here is 53. And that's the main part of the quadratic that is that we do. So if we kept going on this and we were to say, all right, here are my two answers, I'm going to fill in the other stuff, right? So negative b, right? b is negative 5. So the opposite of negative 5 is positive 5. Plus or minus the square root of. Now this is what we calculated. The discriminant is 53. So I know this little part right there is 53. And this is all divided by 2 times a. And a is just 1. So this is going to be divided by 2. And so this is actually our answer. There are two answers here. What I like to do and what I would suggest is to actually break this up into 2 fractions. To write this as 5 over 2 plus or minus the square root of 53 over 2. These are my answers, right? These are my 2 answers that are going to solve this equation up here. And you can see that these answers are not nice integer or rational answers. These are irrational numbers. Our answers are 5 halves plus root 53 over 2. And I'll put these out here just to make it very clear. One of my answers is 5 halves plus root 53 over 2. The other answer is whatever 5 halves minus root 53 over 2 is. And I could approximate those. I could actually plug those into my calculator, because some people get confused at this, and they're looking at the answer as like 5 halves plus or minus root 53 over 2, and they're like, is that my answer? The answer is yes. We have 2 values here and here, and if I actually plug those in, I get 5 halves. Let me plug it in for you. Root 53 divided by 2. This actually gives me about 6.14 if I approximate that and evaluate it. And then the other one, if I do subtraction, I get about negative 1.14. Those are my approximations. These are my approximations. Okay, they're still my solutions, but they're approximate values. Down here, these are my solutions, and this is the exact. These are the exact values, the exact solutions. And so in this section, we're going to be focusing more on the exact solutions, but understand that we can also report those as approximations. Okay. Now, just to show you how this connects to the graph, I'm going to pull up Desmos. So here's Desmos. Now, if I were to go back and graph this, so if I look back at my problem and I look back at my standard form right here, I have x squared minus 5x minus 7 equals 0. Here's how you can make a connection with the graph. You could use your graphing calculator too. But if I put in x squared minus 5x minus 7, there's my graph, right? I could put equals 0 here. That's not really going to, well, we're just going to leave it like that. X squared minus 5x minus 7. We can even graph this as y equals that, right? We're going to graph this parabola. Now, where is y equal to 0? If you look at the 2 zeros here, remember we have 2 answers. On Desmos, I can click on these 2 zeros. There's one of my x-intercepts, and there's another one of my x-intercepts. And you can see that those are the exact 2 answers that we got for our approximate answers, negative 1.14 and 6.14. So it's actually an easy way to check your answers as well. But it's a good connection to make with the graph. So, again, our answers are right here in blue. But our approximate answers are 6.14 and negative 1.14. That's how it connects to the graph. Okay?